Okay, so there's a submarine located in the sea at this is the coordinates relative to a ship positioned at O. X direction is east, Y is north, and Z is vertically upwards, right? So that's important. All distances are in kilometers. The submarine travels with direction vector this, assuming he's moving in a straight line. Write down the equation for the line along which it travels. Okay, so this is easy, guys, if you know how to write the vector equation of a line. It's just r equals a, which is the position vector of a point on the line, so that this is our 0.8, 1.3, negative 0.3. We know this is on the line, and he's moving with direction vector this, so it's just plus t times, or some parameter, you can choose lambda, t or lambda, or any other letter, to be honest, but they're the two we usually use. That's it. That's the vector equation of a line. Done. Part B. The submarine reaches the surface of the sea at the point B. Find the coordinates of point B. Right. So imagine, so this is the sea here, and this is our, let's say our submarine is here, like this. I don't know what a submarine looks like. Right. He is going to move, well he's going to move, he's not moving in a straight line, he's not moving directly upwards, but let's say he's moving like this, he's approaching the surface. So where is this ship located at the origin? Well, it's on the surface. Obviously the ship is floating on the sea, so it's essentially asking us, it's a kind of a hidden way of asking, find the coordinates when z equals 0, because the z coordinate is the vertical, it's the vertical direction. It says it here, look, z direction is vertically upwards. So it's like saying, okay, we're going to go up until z is 0. What's the point? So when z is 0, minus 0.3 plus t, plus 1t if you like, has to equal 0, and t has to equal 0.3. So if t is equal to 0.3, I can say when t equals 0.3, or equals 0.8, 1.3 minus 0.3 plus, now t is 0.3 times -2, -3, 1, which is equal to, just move down here, 0.8 minus 0.6 is 0.2, 1.3 minus 0.9 is 0.4, and this we know is going to be 0. So the coordinates of P, I'm going to write it as a point, guys, just be careful. You'd probably get the marks for that, but you got to be clear on the difference between a point and a position vector, even though they're quite similar. 0.40. So this is the point P. Okay, finally, part 2, B part 2, it says find OP. Now, OP is the distance OP. When they just write two capital letters like that, it's the distance he's after. So OP is equal to the square root of, so it's this, it's the distance formula, it's in the formula booklet, but it's this minus 0 squared plus this minus 0 squared plus this minus 0 squared, which is essentially 0.2 minus 0 squared, which is 0.2 squared, plus 0.4 minus 0 squared, which is 0.4, plus 0 minus 0 squared, which is obviously 0. This gives us the square root of, obviously, guys, you can use a calculator, but it's 0.04 plus 0.16, which is actually root 0.2, and the square root of 0.2 is 0.447214. 0.447214. 447214, or 447 to 3 significant figures. Okay, that's question 13.